Hi there. Today's lesson is on surface area and volume of a sphere. And if you've noticed that all the lessons seems like you're just plugging in the numbers into the equations. So if you feel like that's the case for you and you're going through the questions on your own, that's completely okay. Just please make sure you come to class with a good understanding of how to use the equations. And make sure that you are copying down all the right steps. Okay, so if you're missing a step, please make sure to include it. So if you're pausing and kind of forwarding a few minutes to see what I write, that's okay. Just make sure you're checking your work, okay? So try to visualize a sphere, and if you do that, you'll hopefully be able to imagine the radius of a sphere, which is kind of the only variable you need to know in order to calculate surface area and volume, okay? So the radius of the sphere would be from the center of that sphere, oops, I need to reorient, to the outermost region of it. Okay, so for this question, you're told that a basketball has a radius of 12 centimeters. So R is equal to 12 centimeters. And it's asking you how much leather would be required to make this ball. So is this asking us to solve for volume or surface area? If we're trying to figure out how much fabric it would take to cover up the exterior, hopefully you can see that it's asking for surface area, and we know that that's equal to 4 pi r squared. By the way, the smartboard's acting kind of funny, so if it does something strange, like with the number 4 there, bear with me. So when you plug in what you need to, times 12 squared, you can see that surface area turns out to be 0.18 meters squared. Well, actually, I'll backtrack a little bit, because first you figure out that it's in centimeters. So first, your original number is the following, 6.4. So your number is in centimeters squared. But the question is actually asking you for a cost. So it says, if leather costs $21 per square meter squared, how much is it going to cost to cover up this basketball? Well, the cost is given to you in meters squared, but your answer for surface area is centimeters squared. So we have to change one of the units to the other. So we have to change the centimeters squared to meters squared. Now, on the test, I'm not going to be asking you for conversions, so don't worry so much for this being on the test, but you already know that 1 meter is equal to 100 centimeters. However, because this is squared, typically we would move this over 2 times, because there are 2 zeros to convert to meters, okay? So 1, 2, but because it is squared, we're actually going to move the decimal to the left 4 times, okay? And so if you convert centimeters squared to meters squared, you have to divide by 10,000, okay? So to convert to meters squared, you would end up with 0.180864 meters squared. So that's how much material we would need. Now, every meter costs $21. So we're not even using 1 meter, which means that it's not going to cost us more than $21. How do we figure out the cost for using this material? Well, hopefully you can see that we would have to take 0.18, and I'm just going to round to 1 of the meters squared, and then times that by the $21, right, per meter squared. Well, that gets rid of the meters, and it leaves us with a cost of $3.78. So if we needed 2 meters squared of fabric, we would multiply by 2, but we only need 0.18, so we multiplied by 0.18. And so as a final statement, therefore, it will cost $3.78 for leather to cover the ball. Okay, what I want you to do here, for example, 3. Oh dear, I just realized I missed example 1. I'm terribly sorry. Oh, I'm sorry, I missed example 1. We can take a look at that in class if you like. I think it's pretty straightforward. But with number 3, I want you to read the question and draw a picture for me, and then come back and check. So pause, draw a picture, and come back and take a look at what I have. Okay, I think the question requires to give you a little more detail for you to have a good understanding. So in case it's not clear, it is asking you to calculate the air outside of the tennis balls. So it's asking you to calculate this air, this volume of air, this amount of air. So the space taken up here, okay? Not the air inside the tennis balls. And if you think about this cylinder, and the sizes and the dimensions, well, it tells you that the tennis balls, right, they have a diameter of 4.6. So that means the radius, right, would be 2.3, okay? And it also says to you that each has a height of 4.6. Because it's a sphere, the height is going to be the same, right? So that height is 4.6. Because we're assuming the tennis balls fit perfectly inside this cylinder, that tells us the height of the cylinder, right? The height of the cylinder. And what would be the height of the cylinder? Well, if each tennis ball has a height of 4.6, it's going to be 4.6 times 3. Oops. 4.6 times 3, so that gives me 13.8 centimeters. Now, if you take a look at your pink sheet, to calculate the volume of a cylinder, okay, you need pi r squared times height. Why do we need the volume of the cylinder? Well, if we can figure out the volume of the cylinder, and we know the volume of each tennis ball, then we can find out all the volume that's left for the air to fill in. So plugging in all the information, you have, now this is the radius here that we calculated, right? Because the radius of the tennis balls is the same as the radius of the cylinder, okay? Times the height we just decided on, 13.8. And so the volume of the cylinder is 229.23 centimeters cubed. Okay. Now, how about the volume of each of the tennis balls? Okay. Actually, I'm going to combine it into all 3. So the 3 tennis balls. Okay. So volume is going to be, because there's 3 of them, it's going to be 3 times, okay? And now how do you get the volume of the sphere? So remember, the volume was 4 pi r cubed, right, divided by 3. So 4 and then times 3.14 pi times the radius, 2.3 cubed. Divide all of that by 3. Okay, close bracket. Okay, you may not have done this, but you can actually calculate or cancel these 3's out. If you didn't, you should still end up with the same number as I do. So if I carry on here, I would be left with, I would do the exponent first here, multiply by 3.14 and then by 4. So the volume is 152.82 centimeters cubed. And now this is for all 3 tennis balls. You may have calculated the volume of one tennis ball and then just multiplied it by 3. But then to finally answer the question, the volume of air is going to be the volume of the cylinder, right, minus the volume of the 3 tennis balls. So that gives you you should end up with 76.41 centimeters cubed. Okay, in this question you were told the surface area of a sphere and you're asked to find its volume. So to find volume, okay, the equation is 4 pi r cubed divided by 3. What do you need to find the volume? Well, all you need is r, which we don't have from this question. But what we do have is the surface area. So we also know that surface area is 4 pi r squared. Now, we know the surface area. It's given to us in the question. 4 is a constant. Pi we know. So can we solve for one unknown? And the answer is yes. So hopefully you remember your algebra. So plugging in what we know, okay, is equal to 4 times 3.14 times r squared. Well, let's try and simplify that as much as we can. 4 times pi ends up being 12.56, and then r squared. Now, we want r by itself, right? We want to solve for r. So we have to move the 12 over. And so to do that, we're going to divide 314.2 by 12.56. That will equal r squared. And that should give you 25.02. That's equal to r squared. Well, to get r by itself, you take the root, the other side, and you end up with roughly 5 centimeters for the radius. So now that you have radius, now you can actually take the radius and plug it into your equation for volume, right? So plugging that in, you have 4 times pi times 5 cubed divided by 3. So volume should be 523.3, centimeters cubed. I apologize for missing question or example number 1. So here's the work for that. Just check your work. Make sure you have the right answer. And I'll see you in class tomorrow.